On to the no calculator part of the review. So this goes all the way back to 4.1. The angle is given in standard position, meaning the initial side is on the x-axis and the terminal side is somewhere else. Determine the quadrant in which the terminal side of the angle lies. So hopefully this is a little easier now that we've had some more unit circle stuff. But remember, you're basing this off of like 0, pi over 2, pi, 3 pi over 2, and 2 pi. So 10/13 is more than 1/2, but less than 1. So this is in quadrant 2. 600 degrees is more than a full circle, so I need to figure out how much more. So subtract 360. Right, so that's 240 degrees. So 600 is a full circle plus an extra 240. So really the question is, where does 240 degrees lie? And that is in quadrant 3. Negative angles just rotate the other way. So if it were 7 pi over 8, it'd be in quadrant 2. So it'd be like that. So we're just rotating the same amount into quadrant 3 because negative angles go down and around. So this one is in quadrant 3. Negative 290, same idea. It's more than negative 180. 290 is past negative 270, so that would fall somewhere into quadrant 1. 17 pi over 12. This is helpful if you think of this as a mixed number. 17 over 12 is 1 and 5/12, which is not quite 1.5. So if you're not yet at 1.5, if you're not at 3 pi over 2, you're just short of that. So this is quadrant 3. 3.14 radians. So be careful with this. We know that pi is about 3.14, but pi is 3.14, I don't know, 159. That's about as far as I know. But pi is a little bit more than 3.14. So kind of a trick question here. You're not exactly at pi. You're a little bit short of that. So you're in quadrant 2. All right, find one positive and one negative coterminal angle for theta. So one positive, one negative. The idea here is that you're adding and subtracting a full circle, but you might have to do that more than once if the angle is bigger than a full circle to begin with. So if the angle is 3 pi over 10, we should be adding and subtracting 2 pi. Well, 2 pi is equal to 20 pi over 10. So one positive coterminal angle is 23 pi over 10. And then one negative coterminal angle is 3 pi over 10 minus 20 pi over 10. Make sure that you're doing theta first, plus or minus the 2 pi. Some of you subtracted backwards, so you had the right values, but your signs were different when we had a quiz. You had opposite signs. This would be negative 17 pi over 10. Those are two positive coterminals. If it's 170 degrees, now I want to add and subtract 360. So if I add 360 to 170, that's 530 degrees. And if we subtract, I noticed some people doing their subtraction wrong, like doing 170 minus 360, like lining it up like this. And even though it says that, you can't do that. Like if you're doing the vertical subtraction method, you need to subtract 170. So I'm just looking at like what's 170 minus, what's 360 minus 170, and I'm just going to make my answer negative. So if you're using this whole like idea from grade school and you're borrowing, which we are, so the answer is negative 190. It's not like I feel like I had some people on the quiz answering like negative 210, I think, if you were trying to go this way, like that's negative 2 and that's 10, and that's not how the borrowing works here. So okay, anyway, 510 is more than a full circle, so you could add 360 to it and get, so it's possible to get 870 degrees. That's fine for an answer for a positive coterminal. But you also, if you subtract 510 minus 360. This answer that you get is going to be positive. Oops. So we're getting 150. That's still positive 150. So 870 could be a positive coterminal angle, but so could 150. So just because I subtracted doesn't mean that's my negative answer. I have to subtract again. So I like to take the positive answer and subtract again. So 150 minus 360, again, line them up. That's 210, but it's negative 210. So that's the first negative coterminal angle you get. And now what I just did there is basically I did 510 minus 720. I just did it in steps. So you could also just think of it that way. All right, we're back to radians. So negative 7 pi over 3. So we're going to take negative 7 pi over 3, add 2 pi to that. So add 6 pi over 3. And it is 2 pi that you're adding and subtracting. On your quiz, some of you just added pi. So this gets me a negative coterminal angle because negative 7 pi over 3 is a little bit over a full circle. So I have to add 2 pi again to that answer to get a positive angle. So 5 pi over 3. You could also subtract 2 pi over 3 and get negative 13 pi over 3. That's another answer for negative coterminal. Negative 75 plus 360. All this fun stuff from grade school, all our borrowing. So that's 295. And then if we do negative 75 minus 360, that's going to add up to what? 1,135, I think. Negative 1,135. Oh, wait, no, I just did 750. Gosh. That would be 750 and 360. I guess I shouldn't have skipped that over. How about this? Negative 435. Better. All right, and then 7 pi. So this one, now think about this. If you just are trying to come up with positive and negative coterminal angles, where does negative 7 pi land? I mean, you can add 2 pi to this. You can still do this and get negative 5 pi. So there's a negative coterminal. And you can keep going. Or you can just say, okay, this is 0, this is 1 pi, this is 2 pi, 3 pi would be here, 4 pi, 5 pi. So all the odd pi's are on the left side of the unit circle, and all the even pi's are on the right side of the unit circle. And that's still true even if they're negative, right? So negative 7 pi is the same as a coterminal angle is the same as pi. That's a positive coterminal angle. Negative 5 pi is fine. You could also say negative 3 pi. You can go the other way. Negative 9 pi would be fine. But all of those are negative, so you have to keep adding 2 pi until you finally, negative pi would be fine. You have to keep adding 2 pi until you get to positive pi. All right, so any of these are fine, but you definitely have to get to positive pi for this one. All right. And for my answer key, I think I'm just going to answer negative 5 pi, and then dot, dot, dot. Get down to this. So if we added, I guess we'd have to add 8 pi eventually to get to pi. All right. Next section. Find the complement and supplement of each angle if it exists. So remember, complements add up to 90. So you're going to say 90 minus 48 degrees for the complement. So 90 minus 48 is 42 degrees. And the supplement is 180 minus 48. So that gets me to 132. If we're in radians, then instead of 90 minus the angle, it's pi over 2 minus the angle, and then you've got some common denominator work to do. That's 9 pi over 18 minus 4 pi over 18, which is 5 pi over 18. So there's the complement. Supplement is, instead of 180, it's pi minus 2 pi over 9. 9 pi over 9 minus 2 pi over 9 is 7 pi over 9. 184, there's no complement because that's greater than 90 degrees. And there's no supplement because that's already greater than 180. So no negative answers for complements or supplements. And then 10 pi over 11. Now, maybe you recognize 10 pi over 11 is bigger than 1/2 pi. Or if you start setting up the math, pi over 2 minus 10 pi over 11, you're going to get something negative. So that's also no solution. We do have a supplement, though. Pi minus 10 pi over 11. 10 pi over 11 is not more than 1 pi. So 11 pi over 11 minus 10 pi over 11 is 1 pi over 11. Next section is just a speed quiz, so going through how we do this again. Now, if you want to try to draw the entire unit circle, you would probably have time, I would think. But if you're worried about time, then maybe you're just going to draw a portion of the unit circle like I do. So I like to draw the quadrant 1 angles, pi over 6, pi over 4, pi over 3. Pi over 6 is radical 3 over 2, 1/2. Pi over 4, both radical 2 over 2's. Pi over 3 is just switching the x and the y, so it's 1/2 radical 3 over 2. And then you can either do all students take calculus to remind you which trig functions are positive in each quadrant, or some people also like doing this. If you're not going to draw the entire unit circle, just to remind yourself how the x and y values should come out, positive or negative. This accomplishes the same thing as all students take calculus, hopefully. So cosine of 60 degrees is the x coordinate at 60, so that's 1/2. Cotangent of 150, so 150 is the 30-degree angle. That's its reference angle in quadrant 2. Cotangent is x over y, so radical 3 over 1. And in quadrant 2, cotangent's negative, so negative radical 3. Simplify that. Tangent of 4 pi over 3. So at pi over 3, we're talking about y over x. And this is in quadrant 3, so tangent is negative, which is positive radical 3. Tangent of pi over 4 is 1. 7 pi over 4 is in quadrant 4, so negative. Tangent of 210, that's the 30-degree angle that is in quadrant 3. So I'm looking at the 30-degree angle, or the pi over 6, and I'm saying y over x is 1 over radical 3. You're in quadrant 3, so it's positive. So rationalize for your final answer. Just box all of these in. Secant of pi over 4, I have this one memorized. It's radical 2. That way I don't have to do 2 over radical 2 and simplify. And then in quadrant 2, secant's negative. Sine of 3 pi over 2, we're looking at the y value at the bottom of the circle. Sine of 2 pi, we're looking at the y value at 0, which is 0. Sine of 300, that's the 60-degree angle that is down here in quadrant 4. And people are asking, like, how do I know that's a 60-degree angle? Either think about how many degrees away from the x-axis it is. It's always the x-axis. So its reference angle is 60. It also lines up with the 60 degrees vertically here. So it's whatever one you're lining up with, or sideways, which one you're lining up with this way. Anyway, sine of 60 is radical 3 over 2, and we're in quadrant 4, so negative. Sine of 225, so sine of 45 is radical 2 over 2. 225 is in quadrant 3, so make it negative. Cosine of 45 is also radical 2 over 2. 135 is in quadrant 2, so make it negative. Cosecant of pi over 4, again, I have secant and cosecant memorized. The reciprocal of radical 2 over 2 is radical 2, and you're in quadrant 1. The x value at 0 degrees is 1. the x over y at pi over 6. So pi over 6, because I don't want to keep scrolling. Pi over 6 is this coordinate. So x over y is radical 3 over 1. And you're positive in quadrant 1. So just radical 3. Cotangent of pi over 2 at the top of the circle there. X over y is 0 over 1. So that's 0. You have to simplify that for the test. Cosine at pi over 6 is radical 3 over 2. And because you're in quadrant 3, it's negative. The secant of 11 pi over 6, so take the x value at pi over 6 and flip it, 2 over radical 3. And in quadrant 4, we're positive, so 2 radical 3 over 3. The secant of 270, so flip the bottom x, or flip the x coordinate at the bottom of the circle, that's undefined. Cosecant of 180, so cosecant of 180, I think my pen might be messing up. There we go. Cosecant of 180 is the reciprocal of the y value at 180. So the reciprocal of 0 is undefined. Cosecant of 120. So 120 is the same as pi over 3 as far as coordinates go. So I'm looking at the y value and flipping it. I'm in quadrant 2, so this is positive. So then I rationalize my denominator, 2 radical 3 over 3. And that was the final one. All right. For this next part, find the exact value of the 6 trig functions of theta. The terminal ray passes through this point. So you're given an ordered pair, which is an xy. You can sketch the ordered pair if you want to. It's negative 5, 12. And remember, for the 6 trig functions, you need to know x, y, and r. R is the radius. It's also found by saying x squared plus y squared equals r squared. So if you know your Pythagorean triples, r is equal to 13. And r is always positive, so it's only x and y that can be negative. So sine theta is equal to y over r, 12 over 13. Cosine theta is equal to x over r, negative 5 over 13. Tangent of theta is equal to 12 over negative 5. Cosecant theta goes with sine, so the reciprocal of that is 13 over 12. Secant goes with cosine, so the reciprocal is 13 over negative 5. And cotangent goes with tangent, the reciprocal is negative 5/12. In quadrant 2, it makes sense that everything's negative except sine and cosecant. For this next one, I really only have to find the remaining 5 because I have tangent. Tangent is equal to 6, which remember, tangent is positive and cosine is less than 0, which means negative. So which quadrant does that happen in? Tangent's positive in 1 and 3, but cosine's negative in 3. So we're in quadrant 3. That's important to know because in quadrant 3, the points are negative x, negative y. And if tangent is equal to 6 over 1, tangent theta, 6 over 1, that's equal to y over x. But the reason it's positive is because it's really negative 6 over negative 1. And I know that because I'm in quadrant 3. So I've got negative 1 for x, negative 6 for y, and then r is equal to the square root of 1 plus 36, so radical 37. All right, so sine of theta is equal to negative 6 over radical 37, which you need to rationalize. So negative 6 radical 37 over 37. Cosine theta is equal to negative 1 over radical 37, which is equal to negative radical 37 over 37. Tangent was already given as 6. Just write it down for symmetry here. Cosecant theta is equal to, I'm going to flip the original version, so negative radical 37 over 6. Secant theta is equal to, flip this first one, negative radical 37. And cotangent theta is equal to 1/6. we should at least be able to get cotangent if I give you a tangent, even if you forget how to do everything else. So make sure you're writing something down for these. Next one says cotangent theta is undefined. So remember, cotangent theta is x over y. So if this is undefined, it means that I know y is 0. I don't know if x is the plus or minus 1, though. So here's what I've got it narrowed down to so far. Y is 0 here and here. But then this stipulation says theta has to be between pi over 2 and 3 pi over 2. So that restricts you to the left side of the circle. So that's how I know that I'm on the left side, -1, 0. So I base everything off of this one point here. So sine of theta is the y value, which is 0. Cosine theta is the x value, which is -1. Tangent theta is y over x, which is 0. Cosecant theta is undefined, the reciprocal of 0. Secant theta, reciprocal of -1 is -1. And cotangent was already given. I'm just going to write it again. All right, and then this one, cosine theta is equal to 0. So this means the x-coordinate is equal to 0. So go back to the circle again. X is 0 at the top and the bottom of the circle. And then this says that theta is between pi and 2 pi. So now we're restricted to the bottom half of the circle. So that means that we have to be down here, which is at 0, -1. So sine theta at the bottom of the circle is -1. Cosine theta was given to me as 0. Tangent theta is -1 over 0, which is undefined. Make sure you write undefined. Don't just leave it at -1 over 0. Cosecant theta is -1. Secant theta is undefined, the reciprocal of 0. And cotangent theta is equal to the reciprocal of undefined, which is 0. In the figure below, the measure of angle COB is 7 pi over 4. So this theta is 7 pi over 4. The radius has a circle of 2. I can see that in the picture, by the way, but they did tell us that. So r equals 2. Find the exact coordinates of point B. So point B, remember coordinates x, y can be calculated by r cosine theta, r sine theta. This is what the entire AP classroom was based on. And some of you did well with this, and some of you need a bit of practice. So that's why I pulled this again. So 2 times the cosine of 7 pi over 4, and 2 times the sine of 7 pi over 4. I think if you struggled in AP Classroom, part of it was just you needed to get stronger on your unit circle trig. So at 7 pi over 4, this ordered pair is negative, no, it's not, it's positive radical 2 over 2, negative radical 2 over 2. That's in the unit circle. And so all we're saying is we've got to multiply that by the radius, which is 2. So 2 times radical 2 over 2 is just radical 2. And 2 times negative radical 2 over 2 is just negative radical 2. So point B has these coordinates on this circle. 31, in the xy plane, the terminal ray of angle theta in standard position intersects a circle with radius 10 at this point. Given that theta is between 0 and 2 pi, find the value of theta. So you can sketch this out a little bit if you're not quite sure. Like, I know I've got a circle. The radius is 10. I need to plot this point. 5 radical 3, -5. So, I don't know, it's down here somewhere, let's say. I might not have placed it in the proper, it should probably be over here, I guess. Just fix that. But again, it doesn't, just do the math so that it doesn't quite matter where you place it. What do I mean by just do the math? We're basically going in reverse of what we just did. If we have the ordered pair and we're trying to come up with the theta here, we can say, well, I know that the x coordinate, 5 radical 3, is equal to the radius 10 times the cosine of theta. And I know that the x coordinate, the y coordinate, -5, is equal to the radius times the sine of theta. So let's solve for cosine theta, so divide by 10. 5 radical 3 over 10 is really radical 3 over 2 equals cosine theta. We've solved this problem before. What angle makes theta equal to radical 3 over 2? Well, the reference angle here is pi over 6, right? And I can see that I'm in quadrant 4. Oh, quadrant 4, I must wrote 5. So what is the pi over 6 angle in quadrant 4? It's 11 pi over 6. And then just double check that works here. If you divide by 10, you get negative 1/2 equals sine theta. So which angle makes sine theta equal to 1/2? The reference angle, again, is pi over 6. And yeah, sine's negative in quadrant 4, but I know we're in quadrant 4 based on where the point is. So that also checks out that it's 11 pi over 6. I took both of those from AP Classroom and just kind of changed some numbers. So feel free to go back into your AP Classroom and look at some of those problems again, especially if you missed them. What we just did is relevant for this section. So find theta between 0 and 2 pi. This would be no calculator. First, find the reference angle. Now, in this one, tangent has been rationalized. So remember, before this got rationalized, it was 1 over radical 3. And if you can't remember that, then multiply by radical 3 over radical 3 and simplify what you get. The reason I do that is because I want this to be in terms of my unit circle. So y over x. So which angle, let's draw our unit circle points again. If you've drawn this enough times that it's annoying, that just means that you know it really well, I hope. You don't have to draw the whole thing every time, but it's helpful to have the visual. So which one of these coordinates has a y value of 1/2 and an x value of radical 3 over 2? The 2's have been canceled, but that's what we're looking for. That's at pi over 6. So the reference angle is pi over 6. The quadrants are based off of the fact that tangent's positive. So tangent's positive in quadrants 1 and 3. And so theta is the pi over 6 angle in quadrant 1 and the pi over 6 angle in quadrant 3. For the next one, the reference angle, what makes cosine theta equal to 1/2? So which one of these three ordered pairs has an x coordinate of negative, well, of 1/2, not negative? That's pi over 3. It's up here. And then address the negative. Let's do this. Cosine theta is negative in quadrants 2 and 3. So your answer for theta is in quadrant 2, it's 2 pi over 3. And in quadrant 3, it's 4 pi over 3. Remember the patterns for those common angles. The numerators are one less than the denominator in quadrant 2, and they're one more in quadrant 3. Secant theta equals radical 2. Now, radical 2 is involved, so you really shouldn't need to rewrite this to say what's the reference angle. If radical 2 is involved, the reference angle is pi over 4. Don't think too hard about that. Secant goes with cosine, though. So just FYI. So what that means is I should be thinking about where is cosine positive. Cosine is positive in quadrants 1 and 4. So in quadrant 1, we're at pi over 4. In quadrant 4, we're at 7 pi over 4. All right, sine theta equals -1. When is the y coordinate -1 on the circle? So that's not one of our 1/2 radical 3 over 2, radical 2 over 2. That means you're somewhere here, and it's at the bottom of the circle. Bottom of the circle is 3 pi over 2. So this type of problem does not use a reference angle, and you're not figuring out which quadrant you're in because you're not in one. You're just picking the correct coordinate and writing the answer. Same idea for this. Cotangent is x over y. So whether y is plus or minus 1 doesn't matter. It's just x has to be 0. X is 0 at the top of the circle and at the bottom of the circle. So this has two answers here. Theta can equal pi over 2, top of the circle, or 3 pi over 2, bottom of the circle. And when is cosecant theta equal to -2? I do like to rewrite this one. Sine theta is equal to -1/2. That's just the reciprocal of 2, or -2. So what's the reference angle? We're back to our quadrants. The reference angle is pi over 6. That makes the y-coordinate 1/2. Sine is negative in quadrants 3 and 4. So the answers I give are 7 pi over 6 and 11 pi over 6. What are the answers to problem 37, what we just did, if I want all possible solutions for theta? So how do I make those answers infinite? I want to make an expression that represents all the coterminal angles to 7 pi over 6. So you always just add 2 pi k. This means any multiple number of full circles I add or subtract to this. So I need them to be full circles. So k has to be an integer, a positive or negative whole number, to make that true. So add 10 full circles, subtract 500 full circles, whatever. There are an infinite number of possibilities for this. Do that for both answers, though. So the other answer is 11 pi over 6 plus 2 pi k. And again, k is an integer. You can use the abbreviation for k as an integer if you want to. I think of it as kez in my head. K is an element of the integer number set. You don't have to use that. It's just if you want to. The AP test always writes this out in words. All right, that's it for our non-calculator part. Please come see me in office hours if you have any questions.